The guy who invented context engineering just revealed why 90% of AI generated code is slop and how to fix it. Dex Horthy from HumanLayer dropped a masterclass on solving hard problems in complex code bases, not toy projects, real 300,000 line production code. His team shipped a week's worth of work in 7 hours. No slop. Passed expert code review. This is the system. Comment context for the full cheat sheet. Here's the problem nobody talks about. Stanford surveyed 100,000 developers. What they found, most AI generated code is just reworking the slop you shipped last week. AI works great for greenfield projects, new dashboards, small apps, but real production code bases, 10-year-old Java, complex Rust, the agents fall apart. Too much slop, tech debt factory. Most engineers say maybe when models get better. But Dex found something different. The problem isn't the models. The problem is how you feed them context. This is the core insight. LLMs are stateless. The only way to get better output is to put better input in. Every single turn. When Claude picks the next tool call or writes the next line of code, it's influenced only by what's in the context window, nothing else. So if your context is full of noise, search results, failed attempts, and angry corrections, the model learns to keep failing. This is why yelling at the agent makes it worse. The model sees a pattern. I did something wrong. The human yelled. I did something wrong again. So the next most likely token is another mistake. You have to optimize your context window for four things: correctness, completeness, size, and trajectory. This leads to a concept Dex calls the dumb zone. Your context window has about 168,000 tokens. Around the 40% mark, you start getting diminishing returns. The model gets dumber the fuller your context gets. If you load up a bunch of MCP tools, dumping JSON and UIDs into your context, you're doing all your work in the dumb zone. You'll never get good results. The goal? Stay in the smart zone. Keep your context window lean. The solution is what Dex calls frequent intentional compaction. You compress your context regularly, so the agent always has room to think. Here's the system: research, plan, implement. Three phases, all designed to keep you in the smart zone. Phase 1: research. Launch sub-agents to explore the code base. They read files, understand code flow, find the right functions. Then they compress everything into a short research document, just the files and line numbers that matter. Phase 2: plan. Take the research and create an explicit plan. Exact steps, file names, line snippets, how you'll test after every change. The plan should be so clear that the dumbest model in the world won't screw it up. Phase 3: implement. Run the plan step by step, keeping context low. Every phase compacts the previous one. Research compresses codebase understanding. The plan compresses intent. Implementation just executes. Does this actually work? Dex tested it live. He took a 300,000 line Rust code base, a programming language called BML, and tried to one shot a fix. Monday night, built research, made a plan. Tuesday morning, the CTO saw the PR and said, "Yeah, this looks good. We'll get it in the next release." He didn't even know it was for a podcast. Then they went bigger, sat down for 7 hours on a Saturday, and shipped 35,000 lines of code. The CTO estimated it was 1 to 2 weeks of work, done in 7 hours, no slop, merged into production. Here's a critical insight about subagents that most people get wrong. Subagents are not for anthropomorphizing roles. Don't create a front end agent and a back end agent and a QA agent. That's cargo cult thinking. Subagents are for controlling context. You fork a new context window to go explore something specific. It reads files, searches code, understands structure, then returns a succinct summary back to the parent agent. The parent agent stays lean, reads one file, and gets straight to work. This is how you avoid the dumb zone while still working in massive code bases. How do you onboard agents to your code base? Most people create one big Claude MD or cursor rules file. Problem: as your code base grows, that file gets enormous. Your agent spends all its smart zone just reading the onboarding docs and then does bad work in the dumb zone. Dex's solution: progressive disclosure. Put a small context file at the root of every repo. Then, at every level, subdirectory, package, module, add more specific context. The agent only loads what it needs based on where it's working. But here's the catch: these docs go stale. Every time you ship a feature, the docs need updating. Dex's preferred approach: on demand compressed context. Don't pre write docs. Instead, launch subagents to take vertical slices through the actual code and build a fresh research document every time. You're compressing truth, not opinions. Now, the part most people skip: mental alignment. What is code review actually for? Most people say finding bugs. Wrong. Code review is about keeping your entire team on the same page about how the code base is changing and why. When you're shipping 2 to 3 times more code with AI, this gets critical. Dex's team puts their AMP threads, the actual agent conversation, on their pull requests. So reviewers don't just see a wall of green code, they see the exact steps, the prompts, and the manual tests. This takes the reviewer on a journey. Plans become the compressed version of intent that keeps everyone aligned. The most important rule: do not outsource the thinking. AI cannot replace thinking. It can only amplify the thinking you've done or the lack of thinking you've done. A bad line of code is a bad line of code. A bad part of a plan could be 100 bad lines of code. And a bad line of research, a misunderstanding of how the system works, will send everything in the wrong direction. This is why you, the human, must read the research and the plan before implementation. The highest leverage work is reviewing research and plans, not reviewing code. Move your effort upstream. Practical tips: you don't always need full research plan implement. Changing a button color? Just talk to the agent. Small feature, quick plan, no research. Medium feature across multiple files, one research, one plan. Complex cross repo problem? Full research plan implement with sub-agents. The ceiling of problem complexity you can handle goes up the more context engineering you do. How do you learn? Reps. You will get it wrong. Sometimes too big, sometimes too small. Pick one tool: Claude Code, Cursor, Codex, and get reps. Do not mind max across tools. And watch out for tools that just spew markdown to make you feel productive. That's not thinking, that's vibes. The gap is real. Staff engineers who don't adopt AI are falling behind. Junior engineers who use AI without context engineering are producing slop. The engineers who thrive are the ones who learn to control context. This is the most important skill in software engineering right now. Subscribe for more deep dives. Comment context for the full cheat sheet. And if this changed how you think about AI coding, smash that like button.